Hello viewers, welcome to add-on. In this question, we are asked if a transistor has collector base junction forward biased and the other junction reverse biased, will it work? And the second question is how much the two transistor junction be biased for proper transistor amplifier operation? And the third is a numerical problem. So let us start with the first problem. We know that a BJT or a transistor has three terminal: emitter, base and collector. Okay. This emitter is made of n-type material, the base is made of p-type material, and the collector is made of n-type material for a NPN transistor. Okay. So this is like this: emitter, base, collector. This is n-type, this is p-type, this is n-type. Okay. So here in this scenario, we can form a PN junction considering these two uh, emitter and base terminal. And similarly here we can also create a PN junction considering these two terminals. So this is the EB junction which is formed and this is the CB junction which is formed. In our question we are asked if the CB junction is forward biased and the EB junction is reverse biased. Okay, CB junction is forward biased and the EB junction is reverse biased. What happens to the transistor characteristics? So this is the mode of inverse active. We can say inverse or reverse active. Okay. So the main thing is when a transistor is operated in a reverse active mode, the roles of the collector, okay, the roles of the collector and the roles of the emitter are particularly swapped. Okay. The base emitter junction, which is the EB junction, okay, this junction remains forward biased. Okay. But the base emitter junction is reverse biased and the collector base junction is forward biased. So what happens in this case is that the transistor will remain working or the transistor will work, but it will have a very limited application. And one of the major thing in this scenario, it will be, it won't provide us with a faithful amplification. Okay. So during this mode, what happens? The transistor, as I have said, become less efficient. So it won't provide us with faithful amplification. Okay. So the current flow is primarily from the collector to emitter, but the value of beta, this value of beta, which is the current amplification factor, it will be reduced significantly. Okay. So as the value of beta is reduced, the amplification will be very much less because the emitter and the collector terminals roles become swapped. Okay. So now the emitter terminal is placed in the collector region and the collector terminal is placed in the emitter region. It will be like that. Okay. So they will swap the roles. Okay. So what happens during the normal mode? The emitter provides the electron and the current flows from emitter to collector. Okay. Now when the collector is placed in the emitter mode, the current will flow from collector to emitter. So this is the reverse active mode where the transistor operates in a reverse principle, because in a normal BJT, the current flows from emitter to collector, but in reverse active mode, the current will flow from collector to emitter and the value of beta will be significantly very much low. So the current amplification will be very much low. So it is not used for any kind of application, or even it is used, it has very limited a number of application. Okay. Now the second question that we are asked is how the two transistor junction be biased for proper transistor amplifier operation. So we need to know that the BJT, it operates as a amplifier when the emitter base junction is forward biased and a collector base junction is reverse biased. Okay. So this is the active mode of operation. So in order to BJT, in order to function as an amplifier, the BJT needs to stay in active mode to give us faithful amplification. Okay. So this will be the biasing for the BJT in order to operate as an amplifier. Now the third question we are asked is that the beta of transistor is 100 and the collector current is 50 ampere. Find the value of base current. Okay. So the beta is equals to 100. We know beta is equal to IC by IB, or collector current divided by base current. The collector current is given us as 50 milliampere, which is 50 into 10 to the power minus 3 ampere. And we need to find the value of base current. Beta is also given to us, which is 100. Okay. So 100 is equals to 50 into 10 to the power minus 3 divided by IB. So IB is equals to 500 into 10 to the power, 50 into 10 to the power minus 3 divided by 100. So it will give us 50 into 10 to the power. This is minus 3, this is 2. It will give us 10 to the power minus 5. So if we simplify it, it will give us almost around, we can say 50. If we divide 50 by 100, it will give us 0.5. So it will give us 0.5 into 10 to the power minus 3, right? Because 50 into 10 to the power minus 2, it is equal to 50 by 100. So it will give us 0.5. So we will left with 10 to the power minus 3. So 0.5 into 10 to the power minus 3. So it will be equal to 0.5 milliampere. So the value of our base current will be 0.5 milliampere in this numerical way. So I hope we have all understand that. So one thing I think that I should explain is that why are we keeping this two junction in forward bias and another is reverse biased. Okay. So the main function of BJT I am explaining here. Okay. So the main function of BJT is that the emitter is highly doped. Okay. The base is lightly doped and the collector is moderately doped. Okay. So when the emitter base junction is forward biased, what happens is the potential barrier between these two PN junction becomes lowered. Okay. So as the potential barrier decreases, the electrons from the emitter, as the emitter is N-type, the electrons from the emitter will enter into the base and the holes from the P-type base terminal will enter into the emitter. So during this time, recombination occurs, and from the recombination, what happens is that base current is generated, which value is very low. Okay. As we have seen in this numerical, the value of base current is very low, 0.5 milliampere. Okay. So the main job of the emitter is to provide the electrons as much as possible to the collector region. Okay. So this is our main objective. Okay. So when the electrons enter from emitter to base, out of, if we say 100 electrons are passed from emitter to base, 5 of them will recombine with the holes present in the base because it is slightly low, and rest of the 95% will go to where? Will go to the collector region. Okay. So this is main principle of the BJT operation. Now we can see that the collector base region, this collector base region is what? This collector base region is reverse biased. So when the electrons enter into the base, they will move across to this collector base, we can say collector base depletion region or collector base junction. And the value of collector base is what? The value of collector base is reverse biased, or we can say the value of collector base is reverse biased. So what happens during this time? The collector is more positive than the base. Okay. So these electrons will be swept across the collector base depletion region into the collector. So from this name, we can say that the electrons get what? Electrons get collected at the collector terminal. Okay. And this is also our main principle of the transistor operation. Okay. So what happens in active mode? When we change the base emitter voltage, which is V of B, okay, when we change the base emitter voltage, it will give us change in collector current, because base emitter voltage and collector current are related with each other, which is given by IC is equal to IS exponential minus VB divided by VT, like this. So if we change the base emitter voltage, the collector current will also change, and the voltage amplification is simply obtained by passing the collector current through a collector resistance which is provided in parallel with it. Okay. So in this way, if we do the biasing like this, we can easily use the BJT as an amplifier. Okay. So I think the question is quite clear to all of us. Thank you.